Greetings, geometry students. Welcome to your last unit of geometry. This is a very, very short unit, kind of a different twist than everything we've talked about. I know Unit 7, Unit 8, Unit 9, those were all big units, a lot of ideas, a lot of concepts to be familiar with. This is actually going to be a bit of a reprieve from those. It's a very short unit. We only talk about 3 big ideas or 4 big ideas that you need to be familiar with. And this is all going to happen in the coordinate plane, okay? So we're talking about reflecting in the coordinate plane. So let's look at what we're dealing with here, okay? So a reflection is just this, okay? That's it. You're talking about reflecting, all right? You're talking about taking something and doing what you could call a mirror image of that shape, okay? So the image is just whatever the shape is, whatever the diagram is after reflection. Okay, so this is going to be whatever the shape is, whatever the image is after reflection, and this is going to be kind of your starting diagram. And pre-image and image are things that you're going to have to be familiar with, basically because pre-image and image and pre-image, you're going to start to see those quite a bit throughout this entire unit. So I want to draw your attention to here, because this would be an example of a reflection across the x-axis. So that is your x-axis. So, and if you look, these are going to be perfectly mirror images of each other, okay? So I go from here to here, I go from here to here, and I go from here to here. And if you notice, the ordered pairs, the locations are very similar, very close to being exactly alike with one small detail. So if you're reflecting over the x-axis, what happens? Well, 6, 5 turns into 6, -5. -2, 2 turns into -2, -2. And -1, 7 turns into -1, -7. So everything that really happens is the y's switch signs. Okay, the y's switch signs for the x-axis. And that's a pattern that is true no matter what kind of reflect. So if we're going to reflect on the x-axis, if I'm going to do that, I just need to multiply the y-coordinate by -1. So if I do something as simple as a triangle here, that becomes 0, 2, 2, 4, and this becomes 4, 2. So if I'm going to reflect that, I'm going to multiply all my y-coordinates by -1. So this would be my pre-image. So then my image, I'm going to multiply all those by -2, or by -1, I'm sorry, by -1. So this becomes 0, -2, 2, -4, 4, -2. And all I did was multiply my y values by -1. So 2 times -1 is -2, 4 times -1 is -4, 2 times -1 is -2. And that's all I'm doing. And notice, this is over the x-axis right here. Okay? For the y-axis, it's going to be a little bit different. I'm going to multiply the x-coordinates by -1. So let's just, for example, say I've got a triangle such as this. Okay? So this would be my pre-image. So I've got -2, 3, I've got 2, 3, and I've got 2, -2. So then to reflect this over the y-axis, I'm going to multiply all the x-coordinates by -1. Well, what's interesting is that all that happens is these two stay the same, because that's a line across there. Only now this becomes -2, -2. So my reflection looks like that. You know what? That's not a great example. You know, if you keep it in your notes, it's not a big deal. But let's do something else. Let's do something to where I say, well, let's just go here again. So this would be 1, 1, 1, 4, 4, 1, and 4, 4. If I'm going to reflect it across the y-axis, I multiply all the x-coordinates times -1. So again, this would be my pre-image. Now my image will be over here. So that becomes -1, 1, -4, 1, -1, 4, -4, 4. That might be a little bit better example for you than that first one. So for the x and the y, all I do is I multiply by the other thing by -1. That's all I do. Multiply the other coordinate by -1. So if I'm going x-axis, the y's are getting multiplied by -1. If I'm going y-axis, the x's get multiplied by -1. Now this last one is reflecting over the line y equals x. Y equals x, I call it that perfect diagonal that goes right through the middle of a graph. That is your line y equals x. Okay, so now you're reflecting over this. All that happens, all I do, is I change the x and y coordinates. Okay, so if I have, let's see, if I do this, if I go here, here, and we'll say here, so this would be my image. This is going to be 1, 3. This is going to be 4, 0. And this will be 1, -3. So then to reflect that, I just switch the x and y coordinates. So my new coordinate becomes 3, 1. This new coordinate becomes 0, 4. And this coordinate becomes -3, 1. So there's that triangle reflected. And my apologies, I made a mistake. The red one would be the pre-image, and the blue one would be the image. My apologies for that. That's your image. Okay, so that's reflected across that perfect y equals x diagonal. Okay, so let's walk through a couple examples here. So A will be at -5, 3. So A will be here. B will be at 2, 0. C will be at 1, 2. So C will be right here. So here's my triangle. And this would be my pre-image. So now, so -5, 3, 2, 0, 1, 2. So for the x-axis, I take my y's times -1. Okay, so my new ones are, all I'm going to do is take my y and multiply by -1. So 3 times -1, my new point will be -5, -3. 0 times -1, so that one doesn't change. That is just 2, 0. 2 times -1 is going to be -2. So that will be 1, -2. So now these are my new points. So over the x-axis, so now I go -5, but this time I go down to 3. So that's often A prime, or A with a little tick on it. B doesn't change, so this is also B prime. And C will be right here, so that's often denoted as C prime. Okay, so these are my A, my new A, B, and C. All right, so this would be considered my image. That's all you're doing. That's all you're doing. So it's a good refresher on plotting points and being able to kind of draw shapes in the coordinate plane. but you're also kind of just doing a little mathematical step as well. So now here we have a square, JKLM. So J will be at -4, 6, which will be there. We're reflecting over the y-axis this time. That's this axis. All right, K will be at 0, 6. L will be at 0, 2. And M will be at -4, 2. So here's my square. So that'll be -4, 6, 0, 6, 0, 2, -4, 2. So here's my pre-image. So X and Y. So for the X-axis, I want to take for the Y-axis, sorry, we're reflecting over the Y-axis. That means I want to take all the X's times -1. Okay, so that's -4 times -1. So that will be, my new point will be 4, 6. 0 times -1, no change, so that will be 0, 6. Again, 0 times -1, no change, so that's 0, 2. And again, all I'm doing, I'm taking the X values and multiplying it by -1. So my new points, 4, 6, that will be my new J, or J prime. K doesn't really move. K and K prime are the same. L prime are also the same. And then M will be right here, or M prime will be right there. So there's my new square reflected over the y-axis. So my new square would be my image. Okay. So I like this step just because I think it kind of visualizes what I'm trying to do. I encourage you to do that at least until you get pretty comfortable with it. Don't try and take shortcuts. That will never come back well. So now we talk about a line of symmetry. And a line of symmetry is exactly what it sounds like. Okay, it's a line through an object that, or such that each side is a perfect reflection. So if I look here, does it have a line of symmetry? If you see this very nice picture out of a kaleidoscope, you know, can I have some lines of symmetry? And the answer is yes. If I draw a line right through here, okay, the left side is going to be exactly the same as the right side. So that's my line of symmetry. That's it. Now I can keep going through here. That's also one. That's also one. Sorry, that's going to go right through here. This is going to be one. This is going to be one. This is going to be one. This is also going to be one. Okay, now, they're not all lines of symmetry at the exact same time, but any of these individually would be considered a line of symmetry. So I could say, you know, is this a line of symmetry right here? And that answer would be yes. Okay, so how many did I have? 1, 2, 3. Let's see, 1, 2, 3, 4, 5, 6, 7. I think I had 7 lines of symmetry there. So I'll go through here. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 lines of symmetry. Now here, do they have any lines of symmetry? Well, it's a circle, okay, and circles have an infinite number of lines of symmetry, but if you look inside of here, there's nothing that's a perfect reflection of anything, okay? I can't draw a line here or a line here and have it reflect, so this one's going to be no. You know, if it was just an empty circle, then yeah, I could write, you know, I'd have an infinite number. My number would never stop. But for here, because the inside has got different designs, there's going to be none. No symmetry to be had here. Okay, so if I have just a triangle, how many lines do I have? Well, we're going to hope it's an equilateral triangle. So I would consider that one. I would consider that one. And I would consider that one. That would be my 3 lines of symmetry. Each line is going to perfectly cut it in half, and if it's going to be a perfect mirror image of each other. Don't worry about this. This would be if we had compass and protractor. I would have you draw vertical lines. Oops. That was a terrible line, I'm afraid. Draw vertical lines, mark off measurements, and then draw the reflections over here. So you could draw your new shape over there. Similar here. I would have you kind of draw perpendicular lines and put your new points. But don't worry about this. Here, do I have one line? Yes. That would be the only line. I can't go diagonally. I can't go across. None of those would work. Okay, this one, just no. You know, I can't go diagonally either. This, where are we going to find some symmetry in nature? We end up seeing it a lot of times on butterflies. So this ends up being kind of my line of reflection symmetry. That's kind of what I'm looking at. That's it. Okay, so now do your 10-1 assignment. And then there are no quizzes for these. Okay, there's no quizzes for these. These are just check in the book and see if you're doing them right. Okay. All right. Goodbye.